Now let's use the solver node to dynamically propagate our growth. So let's see how we can do that. And first, let me in here create a grid node, and let me view the result. And here I have a grid, and onto the grid let's scatter some point, and onto the scatter let's uncheck the relax iteration, and let's add a lot more points onto our grid. And in here let's add a sphere, polygonal sphere, and onto this sphere, or maybe onto this sphere, let's change this to primitive for the faster working. And in here let's add a color node in here and connect this. And for this one, that is a white color, which is good. And onto this side let's add another color node, and for this one I'm going to add a color of black. And now let me animate this sphere by creating a simple adding a transform node. Let's add this and connect this, and onto this let's add a translation animation to animate our sphere. And for the animation I'm going to use an assign expression. So let's add an assign, and in here let's add a $F for the current frame number, and we need to adjust its frequency. So let's multiply by this by 3 maybe to create a higher frequency sine wave. And let's close this with bracket, and onto the Z side let's add a cosine for creating a circular motion. So in here cosine $F, and let's change its frequency to 3. And now let's view the result. Okay, and let's rewind and hit play. Okay, and now maybe let's adjust its amplitude so that our sphere travel in more distance. And for that let's multiply by this by 5, and also let's multiply this whole thing by 5 to increase the amplitude, and hit play. Okay, now we have a circular motion. And now let's add an attribute transfer node to transfer the attributes, and I want to transfer the attribute onto my grid points from this sphere. Let's view the result of the attribute transfer. And in here primitive, it's transferring all of these attributes. Let's uncheck since we do not have any primitive attribute, but we have point attribute. So let's select our color CD, and onto the condition let's lower down this threshold value so that it is close to my sphere, and let's hit play. And we may need to increase our grid size. Let's go into the grid and let's increase the grid size until we have our sphere inside of our grid. Okay, that's better. And here as you can see, we are transferring the attribute, but we are not adding a kind of a stroke effect, because we do not have any information what's happened on the previous frame, and it's only looking at where our sphere is at the current time frame. Okay, so if the sphere location is at in here, the attribute transfer node will transfer this in real time. So we need some way to remember what happened on the previous frame so that we can leave a mark or trail for to say. And for that we can use a solver node. Let's add a solver node. So the solver node is a dynamic solver, and it will remember what happened on the previous frame, and we can use this node to accumulate this attribute. Okay, and let's connect this onto our first input, and because it is a top node, we need to dive inside this node. So let's press enter to dive inside. Okay, so now we are in the geometry level again, but if we take a look at our path, here as you can see, we are in several level inside of this node. If we press enter And if we go back by clicking on this solver button, and here as you can see we have a top net, and if we dive inside in here, and now we are in the dynamics section, and in here we have a soft solver node to import our geometry, and now we are back in the geometry level again, but it's a dynamic simulation. And here we have a top import with the labeled previous frame. So here we have the information on what happened on the previous frame. Okay, so what we can do, we can build this attribute transfer whole setup inside of the soft solver to create an accumulation effect. And for that, let me remove these wires from here, or maybe we can create another one inside of the soft solver. So let's connect this one into the initial geometry and that one into the second input. And now let's dive inside, and in here we have these inputs. Okay, so these inputs correspond to these inputs. Okay, and we want to transfer the attribute from the second input, that is the input 2. And in here let's add another attribute transfer as before and connect this. And onto the attribute transfer, let's uncheck the points and let's specify our color CD attribute. Onto the condition, let's lower down the condition. Okay, now let's go back and onto the solver. Let's rewind onto the first frame and reset our simulation and hit play. And now here as you can see we are leaving a mark of trail, because now we are accumulating our attribute and we are remembering what happened on the previous frame. And if I add a merge node in here, we can view our sphere as well. Let's hit play. Okay, and that is very useful for accumulating the attribute. You can use this method to create a character foot plant, or you can leave a mark of foot plant onto the grid or onto the terrain. Okay, that's quite useful. And now let's create our growth solver by using this solver node. And for that, let's create a test geometry rubber toy. And onto the rubber toy, let me scatter some points by adding a scatter node. And let's increase the force count and maybe uncheck the relax iteration. Okay, and in here let's select add a color node in here, and let's add the overall color to black. That is an entire black color. And I can add another color node, and for this one I'm going to select a single point from where I want my growth to start. For example, if I want my growth to start from here, I can select a point, and I'm not able to select. Maybe I need to change the group type to points, and let's try that again. Let's go into the color and now click on this selection geometry button. Now we have the point mode activated. Now I can select any one of these points from where I want my growth to start and press enter. And now we have a one single white point, and from this white point our growth will going to be start. And after that, let's add a solver node in here, and let's connect this, and let's dive inside. And in here let's create our attribute transfer function that we have created. So let's add an attribute transfer node, and for the growth to work, we are going to transfer this onto our first input, which is itself, and we we are going to transfer the attributes from our previous frame. Okay, and let's connect this into our out and onto the attribute transfer onto the points. Let's select our color CG attribute, and also let's lower down the threshold value, and let's go back, reset simulation and hit play. And here as you can see, nothing is happened, and that is because we need to isolate these points from where we want the attribute to transfer, because right now basically we are transferring the attribute on itself. So because it's a one single stream and we do not have another stream, it's just a previous frame. So we need a way to isolate only these white points, and we can use this by adding a blast node in here. Let's add this, and in here let's change the blast to points, and I'm going to blast the points with the color value at CD. If that is greater than, let's say, 0.1, we are going to isolate them, and we are going to isolate them from our previous frame. And let's change this to delete non-selected to only isolate them. Okay, and now let's go back and hit play, and here as you can see our animation is faster. So let's go back onto the attribute transfer, and let's lower down the threshold value to a lower value, maybe 0.1. Let's go back, and here we have a very basic growth solver, and we can play around with the transfer. Let's lower this down to even more, maybe 0.05, and let's hit play, and now we have a slower growth. Okay, and now let's take a look at another technique for creating a growth solver, and that is my favorite node, and that is the pyro source spread node. And for that, let me create a test geometry rubber toy again. Let's add this, and let's scatter some points, uncheck the relax iteration, increase the number of points, and for this time we are going to use a node called pyro source spread. Let me find it. Here we have the pyro source spread. Let's add this, and for this node to work, if I bring up its parameter, it needs the temperature attribute to ignite the fuel and create a burning fire effect. Okay, and for that we need a temperature attribute in here, and for that I'm going to add a sphere node in here, primitive sphere, and I'm going to use a mask from geometry node that we have been using all along. Mask from geometry, that is our attribute, and that is our geometry from where I want my mask to be. Okay, let's go into the sphere, lower down the uniform scale. Now let's add a transform node in here, and let me reposition my sphere from where I want my growth to start. Okay, maybe let me lower this down to even more, 0.1 maybe, and let me place it right about here. And now let's visualize our mask, or maybe we don't need to visualize it from here because we have the visualizer in the pyro source spread. Here we have these visualizer, and we can visualize the total burn. So the color of this bluish color means that there is no burn and the values are 0. And if we take a look at other attribute, temperature and burn, and here as you can see all of these values are 0. And if we take a look at the fuel, here we have the fuel, noised up fuel, and that is because we go into the fuel and injection noise. Here we are adding the noise into our fuel, so maybe we don't need to add that. Okay, so now we have a value of red, which means all of this is a fuel, which is good. Okay, and let me visualize my burn field, or maybe temperature, Okay, now let's introduce some temperature into our the source point by going on to the mask from geometry and renaming this attribute from mask to temperature. Okay, and now here as you can see we have a visualization of the temperature, and if we hit play, here as you can see our growth is stopping, and that is because we have a very high cooling rate, and that is the main tab which will control our growth solver simulation. Okay, and for the cooling rate, let me zero out the cooling rate. We don't want any cooling to be applied. Let's hit play, and here as you can see we have a growth, and right now as our growth is growing, our fire is spreading, the animation is going slow, and we can control this by this rate. Let's increase the rate. Let's increase this to 3 and hit play, and here as you can see now we have a faster growth. And let me go back onto my mask from geometry node, and here let's lower down the radius so that we have just a slightly bit of hard point. Okay, maybe let's lower this down to 0.1, and let's play around with the position, and let's offset this. Now we have just a slight hot area in here. Now let's see if we can able to grow that, and we were not. Maybe we need to bring this a bit closer, something like that. Let's hit play. Okay, so now we are growing, and we can control this noise. If we go into the pyro source spread, we have the diffusion rate, and that is our noise. Let's lower down its element size to create a more interesting shapes in our noise. So let me lower this down to a 0.1. We are creating a very low element size, and let's hit play. And now here as you can see we have a more interesting shape, more interesting noised up growth solver, and that is my favorite way of creating the growth solver. It's highly controllable and it always produces better result. And we can also control the growth direction. If we come over here onto the transform, I can place it anywhere from where I want my growth to be. For example, I want to start my growth from here and hit play. Okay, it's all very procedural and I like that. Let me bring this back in here, right about here, and hit play. Okay, now let's isolate these points by adding a blast node in here, and onto this blast node we can use any of these attribute. We can use the total burn. If we see here, as you can see, we have this burn, we have a temperature which is the same, and we also have a burn. Okay, let's use this attribute for isolating our points, and for that let's go change this to that is our points group. And in here, if we say if our burn attribute, if burn attribute is greater than, let's say, 0.1, if any of these points has been burned, we want them to be isolated. So let me view the result with the blast, and let's change this to delete non-selected and hit play. Okay, so these are our burn point. Now let's make this grow, and to create this effect a bit better, let me add a points from volume node in here, points from volume, and let me remove this node, scatter node. Let's connect this in between, and let's view the result. Here as you can see, we are scattering points in the inside of our geometry, but right now the points are way less. We can change this by adjusting the point separation. Let's lower this down to 0.01 maybe. Now we have a lot more points. Now let's view the result again with the blast node and hit play. Okay, and here as you can see, now we have these attribute growing inside maybe we can go into the pyro source spread and let's disable these visualization by changing this to none. Now we do not have any visualization. Okay, and now let's turn these points into actual mesh again, and for that I'm going to use a node called particle fluid surface, and that node is used to mesh the fluid simulation, and that requires a particles input on its input. So let's connect this. These are our particles, and let's view the result. And here, as you can see, we have our mesh back again. And onto the particle fluid surface, we have an option for the particle separation. Let's use the same particle separation that we have used in the points from volume, which is 0.01. Onto the particle separation, let's change this to 0.01. Okay, now we have a way better result. And onto the voxel size, maybe let's increase the voxel size to create a smooth out effect. And by adjusting the voxel size, we can decrease the resolution. Okay, which is also good for faster playback. We can also go into the filtering and enable the smoothing to further smooth out our mesh. So let's keep enable the smooth option. And for this one, let me create a flip book of this frame, and let me make this window bigger. And onto the flip book, let's create a flip book with new settings. And onto this size, let's uncheck the resolution and let's start our flip book. Okay, the flip book is done, and now our head is cutting off. That is because I did not adjusted my camera angle correctly, but that's fine. Let's hit play. Okay, our rubber toy has been growing, and that is our growth effect.